Hello everyone, my name is Saurabh Singh and today I'm going to teach about the soil stabilization. This is one of the very important topic of advanced geotechnical engineering. This is your lecture number 17 and it is from unit number 2nd. After watching this video, if you have any doubt, you can contact to me and you can also write the email on saurabh.singh@mygyanvihar.com. So come on the learning objective and learning outcome. There is a learning objective to provide the knowledge about the soil stabilization, to involve the application of scientific and technical principle of planning and analysis of soil stabilization along with the soil improvement technique. The student will deserve knowledge of geotechnical engineering practice applied to a real life problem designing of a structure by the stabilization. This is your learning outcome. The student will also understand the theoretical and practical aspect of the soil stabilization, and they will also understand what is the method of soil stabilization. So come on our topic. First one is soil stabilization. Here we will see what is the definition of soil stabilization. Generally, the soil stabilization is termed as the improvement process under the situation when the influence zone is limited to less than 1 meter is called surface stabilization. Geotechnical process of improving the engineering properties of soil. In properties of soil, there is density and shear strength, and C and O factor are improved while compressibility, settlement, and permeability reduce, and making it more stable and durable is called ground improvement. Stabilization of soil implies the modification of the properties of soil, water, air system in order to obtain lasting property which are compatible with the particular application. The parameter involved are properties of soil to be stabilized, plant improvements, project economics, construction techniques, maintenance of the project. These are the some parameters which involve in the soil stabilization. What is the objective of soil stabilization? We will see here. The main objective of soil stabilization is reducing the volume of voids, which will be equal to reducing the porosity. Filling the voids that cannot eliminated is equals to reducing the permeability. Increasing the bonding between grains will be equal to increasing the mechanical strength. There is also procedure, and there is three procedure which is used in the soil stabilization. First one is mechanical, physical, and chemical procedures. Okay. So here is procedure. As I told you, there is three procedure. First one is mechanical, physical, chemical. Come on the surface stabilization. What is the surface stabilization? Surface stabilization can be done by the three methods. First one is mechanical stabilization, physical stabilization, chemical stabilization, and physiochemical stabilization. Come on, the mechanical stabilization. In this technique, mechanical energy is used like roller plate compacted temper by the choice of nature of soil to improve the soil properties by the compaction, preferably for the construction of embankment for the roads, railways, etc. Mechanical stability depend on the degree of compaction. Normally, the compaction is done at a optimum water content. What is the uses of mechanical stabilization? Simplest method of soil stabilization to improve the subgrade of low bearing capacity, extensively used for the construction of base and subbase and surfacing of road. Here is mechanical stabilization, and we will see here what factor affect the mechanical stabilization. The mechanical stability of mixed soil is depend on the following factor. Mechanical strength of aggregate. The mixed soil is stable if aggregate use have high strength. However, if the mixture is properly designed and compacted, even the aggregate relatively low strength can provide good mechanical stability. Mineral composition, the mechanical stability of mixed soil depend upon the Composition of the minerals. The minerals should be weather resistance. Gradation is here. The gradation of the mixed soil should be such that the voids of the coarser particle are filled with the finer particle to obtain a high density. Here you can see the plasticity characteristics. For mud road surfacing, highly plastic soil are used as a binder. They possess greater cohesion, moisture retention capacity, and provide the seal against downward movement of the surface water. For base course, the soil should have low plasticity to avoid excessive accumulation of water, excessive accumulation of water, and the resulting loss of strength. The soil available at the site may seldom meet both requirements. It is necessary to mix soil from the different sources to obtain desired mix. Here is physical stabilization. In this technique, more than two or three soil are blended to improve the physical properties of weak soil. And it is quite often some additive may also be added for the purpose of cement stabilization, lime stabilization, bitumen stabilization, chemical stabilization, and resin stabilization. First, we will see cement stabilization, the most commonly used for the road construction. Heavy clay are difficult to polarize and not suitable. Well-graded sanded and gravel mixture with up to 100% fine binding materials. Quantity of cement to be determined on trial basin in the lab. Minimum strength is required for this kind of soil is 3.5 Newton per mm square. 7 days cube strength. It is your 7 days cube strength. Compaction to be compacted within 2 hours after laying mixing with the water. General plant method is here also faster construction, expensive dry mix, then wet thoroughly the spreading and compaction. Mix in the place method, it is similar to agricultural rotary cultivator. Firstly, soil is polarized, then dry cement is spread over. Then water sprinkled in layer again, remixed and shaped to chamber compacted using ruler. Here is cement stabilization. Normal soil cement is stabilization. It consists 5 to 14% of cement by volume. Cement is sufficient to produce a hard and durable material. Sufficient water be used for the hydration requirement and workability. It is weather resistance and good, strong, and used for the stabilization study and other low plasticity soil. It consists of 5 to 14% of cement by the volume. It has more water to have wet consistency similar to that of plastering mortar at the time of placement. Used for the waterproof leaning of canal and reservoir. Used for the protection of steep slope against the water erosion. Here you can see this is your treated material as you can see here, and this is your milling and mixing drum, and that is your untreated material. And spreading, and it is the image spreading cement ahead on the machine and metered injected to the water. Now you can see here the soil stabilization cement, which is known as glide steps as you can see here. We also need to do the soil stabilization here. And this is your one image by which by where you have to do the soil stabilization by the help of the cement. And after the soil stabilization, your soil look like this as you can see here. There is some stone aggregates and with the cement they are compacted by the roller, and this is the also method of a soil stabilization. And this is the grinder which is used during the soil stabilization process. Now we will see the lime stabilization. There are basically five types of lime as we all know. High calcium quicklime, hydrated high calcium lime, dolomite lime, normal hydrated dolomite lime, pressure hydrated dolomite lime. The quicklime is more effective than the hydrated lime, but the latter it is more safe and convenient to handle. Generally, hydrated lime is used. It is also known as slick lime. The higher the magnesium content of what is the main goal of the compaction? We will see here. This is your first diagram. As you can see, first one is the air, water, and solids, and there is a goal of compaction to reduce air void's volume VA in soil as much as possible. For given water content W, the maximum degree of compaction that can be achieved is when all of the air voids has been removed, that is saturation will be equal to 1. Since, as we know, S will be equal to WGS upon E, the corresponding void ratio for S will be equal to 1 will be E is equal to here, E will become here WGS. Now we will see the principle of compaction. The degree of compaction of soil is measured by the dry unit weight of Scotland. The dry unit weight of soil will be the increase by the doing of the compaction. The more compacted soil, if you will see the more compacted soil, it has more dry density in compared to normal soil. The higher its dry unit weight, GD will be the higher. Now we will see how we calculate the gamma D, which is equal to bulk density of soil. Block diagram is showing first diagram. As you can see, there is air, water, and solids, and total mass will be represented by the M, and it will be MW plus MS. Means MW means mass of water plus mass of solid, and we do not need to take here mass of air because we assume as the zero the mass of air we assume as a zero. Total volume will become here VW plus Vs, and void ratio will be E will be V upon Vs, which is uh, volume of voids upon volume of solids, and water content here will be MW upon Ms, and saturation degree of saturation will be represented by the VW plus VB. And this is the moist soil unit weight, which is represented by the gamma will be equal to MW plus MS divided by total volume, and it will become W plus 1 MS upon V, which will be equal to 1 plus W gamma dash. And in laboratory, we have to use vibrating hammer, which is known as BS. And for fine grained soil, we have to use the falling weight and hammer, kneading compactor, and static load and press. Here you can see in the field we have to use the hand operated vibrator plates, motorized vibrator roller, rubber tire equipment, free falling, compaction vibration, weight and dynamic frequency we can use, and hand operated temper we can also use for the field, uh, and seafood roller which is used in the compaction of soil, rubber tire roll, this is also used for the soil compaction, and standard proctor test. First we will see the standard proctor test, how we will conduct the standard proctor test. As you can see, R.R. Proctor in the early 90s was building dam for the old Bureau of Water Work and Supply in the Los Angeles, and he developed the principle of compaction in series of articles in engineering news report. And variables of compaction is here also. Proctor stabilized that the compaction is the function of four variable, as you can see here. First one is dry density, which is represented by the gamma D, or dry density unit weight, which will be represented by the uh, and gamma D also, and water content W, comparative efforts energy E, and soil type gradation, presence of clay and minerals. These are the variation which affect the compaction, and these are the, you can also say this is the compaction function for the variables. Now we will see the compaction. Proctor test here. Standard Proctor test equipment. There is hammer which weight is 5.5 lb and drop height will be here 12 inch here. Okay. Now come on the volume. Volume of this soil sample will be 1 by 30 feet cubic centimeter, or will be which will be equal to 944 centimeter cube. Diameter will be 4 or 10.6 centimeter. Height will be 4.584. Okay, now come on the equipment needed for the compaction. As you can see here, first one is given standard Proctor mold, which is required one piece. Standard Proctor mold, one piece. Standard Proctor hammer will be required one piece. Extruder will be required one set, and square pen will be required one set. Thin box Tin box will be required 12 pieces. Graduated cylinder will be required one piece. Scoop will require one piece. And trowel will be required also one piece. And these are the equipments which is needed for the doing the compaction of a soil. The soil standard Proctor test. The soil is mixed with the varying amount of water to achieve different water content. For each water content, the soil is compacted by the dropping a hammer 25 times into the confined soil. The soil is mold will be dividing into three lift. Each lift is compacted 25 times, and we can also say each soil will be divided into three layer, and each layer will be compacted 25 times. This is the done 4 to 6 times, and this will be the pattern of doing the compaction here. Now, what is the standard energy? Standard energy is the also factor which involve in the compaction of a soil. Competitive applied to the soil per unit volume will be equal. You can see here, this is the graph which we have to plot during the compaction by the standard Proctor test. Now we will see the Proctor principle of a compaction using a standard energy. If a series of specimens of soil are compacted at increasing water content, the result dry density of a specimen will be vary. The density will be increased to a peak value, then decrease. So you can understand what we have to do. We have to use the water content in a variation, and then we will get the maximum density. Then we have to stop it, and on that point we will get our MMD, which is known as maximum dry density, and after that your density will be decreased as mentioned here. Principle of compaction: a plot of a dry intensity versus uh, the water content from the compaction test will be parabolic in its shape. The peak of curve is termed the maximum dry density, as I told you, MDD, and the water content, which is peak, occur in the optimum water content, which is known as OWC. And here, several standard energies are used for the laboratory of compaction test. First one is the standard, modified, and California, and there is a different value of energies which involve in the doing the compaction of a soil. Now we will see the summary of a standard Proctor test here. As you can see, there that is your hammer, which have weight of 5.5 kg, and there is also drop distance which is given here 12 feet, and uses 5.5 pound hammer, drop 12-inch mold filled in the three lift, 25 blows of hammer per lift. Total energy will be consumed here, as you can see, 12,400 feet lbs per feet cubic feet. And here, as you can see here, that is the same thing. Now we will come on the several standard molds are used depending on the maximum particle size sample. 4-inch diameter mold, which is equal to 1 by 30 feet cubic, used for the low gravel content method. A soil with will be less than 20% of gravel. Method B of soil, where it will be greater than 20% of gravel and 20% larger than the 3 by 8 inch. And several standard mold are used, as you know, for the compaction of a soil. Standardized tests are not available for the soil with more than 30% by the weight of the total sample being larger than 3 by 4 inch in the diameter gravel. ASTM compaction test method are also given here, which is mentioned as here. There is 6 method of ASTM compaction test. And now come on the how you have to do the test of the compaction Proctor test. First, you have to prepare a 4 to 5 specimen at the increasing water content about the 2% apart. Example, prepared is simple at 14, 16, 18, and 20%. Use range of moisture based on the feel and experience. Like here, as you can see here, you have to use the water content in the soil. Like first you have to use the 14%, after that you have to use 16, 18, 20, and you have to repeat this. You have to repeat this percentage of water in the soil till you are not getting your maximum dry density. Here you can see Proctor compaction test summary. Hammer then compacted each sample into the steel mold with the standard procedure, and cured soil is also here and compacted mold is also here. Now we will see the what will be the next. Then strike of axis soil so that mold has known as volume of the soil. As you can see here, we have to strike of the axis amount of soil from this mold so that we can get the exact volume of a soil. Here, as you can see here, laboratory method of determining optimum moisture content and maximum dry density. As you can see, this is your image of mold and standard Proctor mold with the hammer. And here is the method which is invented by the R. Proctor in 1933, which is, as you can see here, your soil layer is divided into 3 parts, and this is there will be used there we have to use 2.kg hammer, and each layer we have to give the 25 blows of a hammer. And now, what we have to do in Proctor compaction test summary, we will see here for each sample measure the weight and the water content of the soil in the mold. The mold volume and weight are pre-measured. Don't assume nominal volume 1 by 30 cubic feet and 1 by 13.33 cubic feet. Calculate the moist density, calculate the dry density, plot dry density and water content for each point. As you can see here, what is the problem? Calculate the moist density and dry density. This will be the formula which we will use during the calculation of the moist soil weight of a soil. As you can see here, this is your formula. And now we have to see the dry unit weight. The compacted soil is removed from the mold and its dry density or unit, which is also known as dry unit weight, is measured by gamma m upon 1 plus w, which is, as you can see, gamma d is equals to dry unit weight, and w will be the water content, v will be the total volume of soil, and m will be the total mass of the wet soil, and g will be the gravitational acceleration. As you can see here, by the here mg upon v, we have to put the data in this formula. We will get the dry unit weight of that soil. And now we will see what is the role of water in the compaction process. Water lubricate the soil grains so that they slide more easily over each other and can thus achieve the more density packed arrangement. A little bit of the water facilitate the compaction. Too much water inhibited compaction. As you can see here, this is your dry unit weight graph where we have to use the soil and we have to do the density. And here is the modified Proctor test was developed. And now we will come on the modified Proctor test. We have done standard Proctor test. It was developed during the World War II by the US Army Corps Engineering for a better representation of the compaction required airfield to support the heavy craft, as you can see here. And in modified Proctor test, same the standard Proctor test of the following exceptions. This is the soil compacted in the 5 layer, and there will be weight of hammer will be 10 lbs, and there is a drop height will be 8 inches. That is the difference between modified Proctor test and standard Proctor test, and this is the graph of a modified Proctor test and a standard Proctor test. You can see here. Now we will see the comparison summary of standard Proctor test and modified Proctor test. Mold size will be 1 by 30 cubic feet, and here will be 1 by 30 feet cubic feet. 12 in the height of drop, here will be the mold height of drop, which is 18 is given. 5.5 lb hammer, and there will be the weight of hammer will be also more in the modified Proctor test, and there will be 3 layer in standard Proctor test, and there will be 5 layer. And this is the difference, which is very important to know. What is the difference between standard Proctor test and modified Proctor test? Now you can see this is your curve will be which you will get in the during the compaction of a soil. Now we will see what is the zero air voids. As you can see here, that is the figure which is showing the dry density and water content relationship, and this is also known as degree of saturation graph. And JAW, as you can see here, which is known as zero air voids. The curve represents the fully saturated condition, which will be where S will be equal to 100%, and JAV cannot be reached by the compaction. Line of optimum, as you can see here, there is one line of optimum, a line drawn through the peak points of the several compaction curve at the different comparative effort for the same soil will be almost parallel to the 100% S curve. And there is also entrapped air, as you can see here in the graph, entrapped air. It is the distance between the wet side of the compaction curve and the line of the 100% saturation. Now we will see the results. What will be the results in the dry of optimum? As the water content increase, the particle develop larger and larger water films around them, which then lubricate the particle and make them easier to be moved about and reoriented into a denser configuration. Here is also hammer impact. It is air expelled from the soil upon the impact quantity is larger than the volume of water added. And here is also weight of optimum. What is the meaning of weight of optimum here? And water, when our water start to replace the soil particle in the mold, and since the rho will be less than ps, and the dry density start to decrease. Hammer impact, what is the hammer impact? Moisture cannot escape under the impact of the hammer. Instead, the entrapped air is the energized and lift the soil in the region around the hammer. So these are the result explanation of a compaction. As you can see here, that is your OMC, and this is your dry side, and this will be your wet side. Means this will be your soil in the dry condition, and this soil will be in the wet condition, as you can see. Now we will see the effect of soil types on the compaction. What will be the effect of soil type on the compaction? The soil type, that is grain size distribution, shape of the soil grain specified of soil solids and amount of type of clay mineral present. As here you can see the compaction characteristics. What is the meaning of the compaction characteristics? We will see here unified soil classification, where is a group symbol GWGP, GWGC, SWSPSM, which will be the meaning of these types of soil will be good characteristics, have a good characteristics of compaction, and SCCL, which is good and fair, RML good to poor, and OL MSCH OSPT fair to poor. And we will see the embankment material. What is the which soil will be good for the embankment of the, like embankment of the wall, embankment of the dam? You can see GWSW will be very stable, CL will be stable, but it will be not like GW and SW. GP, GM, GC, and SC reasonably stable. It will be not as good as the Cl. SPSM reasonably stable when dense. Ml poor gets better when high density, and OH MHCHOPT that are the unstable and poor, and you cannot use this soil for the embankment preparation. And here we will see subgrade material, which is subgrade material means this kind of soil used in the construction of subbase of a road construction or road pavement. As you can see, GW will be the excellent, GPGM will be the excellent to good, GCSW will be good, SPSM SC will be good to fair, MLCL will be fair to poor, and OL MHCHOHPT will be poor to not suitable. It is not suitable material which we can use for this preparation of a subgrade. Now you can see the typical compaction curve for cohesionless sand and sandy gravel. This is the graph which is showing the bulking capacity of a sand and sandy gravel. The low density that is attainable at the low water content is due to the capillary forces resting arrangement of the sand grains. Now we will see water and compaction. What is the relation between water and compaction? Remember, what is the effect? What is the effect of water in the compaction? First, we will see here increasing the water content at which the soil compacted increases the likelihood of obtaining disparate soil structure with the reduced shear strength. Increase the pore pressure in the soil, decreasing in the short term shear strength. So you can understand this is the relationship between water and compaction, and here you can see how water can affect the compaction of a soil. Here you can see this is your graph which is showing the structure of compacted clay, and one will be divided by 30 feet cubic centimeter cubic feet, and it will be equal to 12,375 feet lbs per effect of the compaction on permeability. This graph is showing the effect of the compaction on the permeability at constant compaction effort decrease when increased water content and reaches at a maximum and minimum at about the optimum. If compactive efforts is the increase, the permeability decrease because the voids ratio decrease. This is the graph which is showing relationship between water content and density and water content and permeability. Now we can see here this is the effect of compressibility due to the uh, pressure which we use during the compaction, and magnitude wet side more compressible in low pressure range, dry side is the high pressure range. And what will be the rate? Dry side consolidation will be more rapidly. As you can see, these are the two graphs which is showing relation between pressure and natural scale and void ratio. And this is also for the low pressure consolidation, and this one is for the high pressure consolidation. This graph is showing. Now we will see the compressibility and expansion of a unified soil classification. Here is a group symbol which is also showing the compressibility and expansion of these soil. As you can see here, and these five soil will give the very little, and this is very slight, and this will be slight to medium and medium to high. And this is also the group symbol which is showing the compressibility and expansion relationship of a soil. Now you can see here what will be the effect on the strength. Sample kaolinite compacted dry of a optimum tend to be more rigid and stronger than the sample compacted wet of optimum. Okay, we was on the lime stabilization. The higher magnesium content of the lime, the less is the affinity for the water and the less for the heat generated during the mixing. The amount of lime required varies between 2 to 10% of this fire. Here is the lime stabilization. Lime stabilization is done by the adding lime to soil. So you can understand what we have to do in lime stabilization. We have to use lime with the soil, and it is help to improve the bearing capacity of soil. It is useful for the stabilization of clay soil. When lime react with the soil, there is exchange of cation in the absorbed water layer and a decrease in the plasticity of the soil occurs. The resulting material is more fireable than the original clay and it is therefore more suitable as the subgrade. Here types of lime. Lime is produced by the burning of limestone in clay. The quality of limestone obtained depends upon the parent material and the production process. The following amount of lime may be used for the rough guide. 2 to 5% of clay gravel material having less than 50% of silt clay fraction, 5 to 10% for the soil with more than 50% of clay fraction, about 10% of heavy clay used as a base and subbase. For soil having particle size intermediate between 1 and 2 above, the quality of lime required is between 3 to 7%. Lime stabilization is also not effective for the sandy soil. You cannot do lime stabilization in the sandy soil. Construction method. What is the construction method of a lime stabilization? Construction method is used in lime stabilization are similar to those in cement stabilization. However, the following points should be carefully noted. The reaction in case of lime is slow. There is a maximum time limit between the addition of lime to the soil and the completion of the compaction. Lime may be added in the form of slurry instead of dry powder. A rest period of 1 to 4 days generally required after spreading lime over heavy clay before the final mixing is done. The soil lime is compacted to required maximum dry density. After compaction, the surface is kept moist for the 7 days and then covered with the suitable wearing coat. Chemical and physical changes in the lime stabilization we will see here. Lime react with the wet soil, alter the nature of absorbed layer as the calcium ion replaced the sodium of hydrogen ions. The double layer is disparate due to the increase in creation of concentration but sometimes expand due to the high pH value of lime. Lime react chemically with the silica and alumina in soil and form natural cement composed for the calcium aluminosilicate. In lime stabilization, liquid limit decrease, plastic limit increase. Plasticity increase, index decreases also. Soil become more friable and workable. The strength of soil is improved. Unconfined compressive strength is increased up to 60% and modulus of elasticity of soil also increased. Lime causes decrease in tendency of attraction of water. Soil resists to water absorption, capillary rise, and volume changes on wetting or drying increased. Lime stabilized base and subbase from the water resistance barrier, which stop penetration of rainwater. Optimum water content is increased and maximum dry unit weight is decreased. In swampy areas where water content is above the optimum, it helps in drying of the soil. So we have to do our lime stabilization where we need to improve the bearing capacity of soil. Now we will come on the fly ash soil stabilization. As we all know, fly ash is a pozzolanic material. It reacts with the lime and therefore almost used in the combination with the lime in soil have little or no plastic fine. It has often been not found desirable to use a small amount of Portland cement with the lime and fly ash for added strength. This combination of lime cement fly ash, which is also known as LCF, has been used successfully in the base course stabilization. So this is the ruler by which we can do the soil stabilization by the adding of lime. Here you can see there is a white color which is your lime is mixed with the fly ash, and then we have to mix it with the water and your soil bearing capacity will be improved here. Now as you can see, this is also method of improving the soil bearing capacity by the soil stabilization. After there is 2 ml after before adding the lime and after adding the lime in your surface. These things is generally for conducted for the preparation of pavement and preparation of floor of any important structure. As you can see here, this is also one kind of equipment which is known as pneumatic roller. It is used to improve the strength of your soil. These are the images which has been which is uh, these are the images which is showing the soil stabilization method. Now we will come on the next topic, bituminous stabilization. Here we have to use the bitumen for the soil stabilization. Any organic soil which can be mixed with the asphalt is suitable for the bituminous soil stabilization. In cohesionless soil, asphalt binds the soil particle together and serve as the binding agent. In cohesive soil, asphalt protects the soil by the plugging its voids and waterproofing it. It helps to maintain low moisture content and to increase the bearing capacity. The amount of bitumen required varies between 4 to 7% by the weight. Now come on the MCQs. First question is there. A grilled foundation is provided for heavy isolated column, or it is treated as a spread foundation. Consists of two sets of perpendicularly placed steel beam. So here right answer will be D. All of the above. Come on the next question. Effective stress on soil increase void ratio and decrease permeability, increase both void ratio and permeability, decrease both void ratio and permeability, decrease void ratio and increase permeability. And here right answer will be decrease both void ratio and permeability. Come on the third question. Hydrometer reading are corrected as temperature correction, minuscule correction, dispersion agent correction, temperature minuscule and depression agent correction. So right answer here will be hydrometer is used for the all these points which is given in the D. Right answer will be D. Now on the fourth question, the ultimate consolidation settlement of surface resting on wall decrease with increase in the initial void ratio, decrease with the decrease with the decrease in the plastic limit, increase with the in initial void ratio, increase with the decrease in the porosity of the soil. Here right answer will be decrease with the increase in the initial void ratio. Come on the fifth question. Select the incorrect sentence. In direct shear box test, the plane of shear failure is predetermined. Better control is achieved on the drainage of the soil in the trial and triaxial compression test. Stress distribution on the failure plane in case the triaxial compression test is uniform. Unconfined compressive test can be carried out on all types of soil. Here right answer will be D. As you can see, D will be your right answer. This statement is incorrect. Come on the sixth number question, which is factor safety against sliding of slope is the ratio. Actual cohesion to that required to maintain stability of slope, shear strength to shear stress along the surface, neither A or nor B. Here right answer will be both A and B. D will be your right answer. Come on the seventh question. The angle of internal friction is least for angle grain loose sand, angular grain dense sand, round grain loose sand. And D option is clay, which is your right answer. D will be your right answer. Disparate type of soil structure is an arrangement comprising particle having. Here is option given face to face or parallel orientation, edge to edge orientation, edge to face orientation, and all of the above. Here, right answer will be all of the above. Now, on the ninth question, the neutral stress in the soil mass is force per neutral area, force per effective area, stress taken by the pore water, stress taken by the solid particle. Here, right answer will be stress taken up by the pore water. Now, on the next question, the coefficient of compressibility of soil is the ratio of stress to strain, strength to strain, strength to stress, stress to settlement, and rate of the loading to the that settlement. Here, right answer will be B, strain to stress. These are the very important questions, and these may be asked in your weekly test, and this can be also asked in government exams. Come on, the reference. These are the reference of today lecture. Thank you for watching this video.